Hello everybody, good morning. Well, I guess it's afternoon here, but so we're over in our machine shop here in Lincoln, Nebraska. We're across the street from the Speedway Motors warehouse. I'm here with Dave. He is our machine shop manager here. So now that we've got a couple people on, we can start. So Dave's going to give us a tour of the machine shop over here. He's going to show us how a couple of parts are made in some of our DMG Mori machines and all of our other machines. And we're going to talk to some of the guys here, and yeah.
All right, well, let's go. First one we're going to look at is we're machining a screw-on ball joint, or a weld-on one. All right, go ahead and start her up, Dustin. This is a fairly simple process for us. It's going to start out with the bar feed, then it'll go into a turning the part, and then it'll bore it, cut the threads, and then part it off. What we're doing here is what we call a part handoff, where we grab it with the sub chuck, part it off. That way we deburr the part, and the part comes out of the machine being a 100% finished part. That's a completely finished deburred part, ready to go to the warehouse.
Very cool. Pretty easy. Smooth process.
Now we're going to move on to something a little bit different, drilling some steering wheels. We take a standard steering wheel, load it in the machine in a fixture. This is just something pretty quick and easy we came up with. It goes and drills all the holes radially and axially around the part. Start her up, Eric. Eric's going to show us how he drills them. You can try to cool them on.
Do you need me to move? I'm going to get out of your way.
Nope. Ready to move on?
All right, yep, we're good. If you have questions, leave them down below. I won't be afraid to interrupt Dave at all, so he's happy to answer questions.
On this machine, we're machining some scale platens. These are the two left and right hand sides. We've already did the first operation, and this is the second operation, and there's two more to go after that, then a finished part.
on to the next
There's a
thing.
stack of the flattens he's currently working on.
Hi, Bob, Brian, and Harry. Thanks for watching. It is pretty noisy over here, so we apologize for the background noise, but we can't shut all their machines down today, so. Nice big stack. All right. Hi, John. Thanks for watching.
On this lathe, we're going to show you how we're machining our IMCA spindles. It's forging we start out with is 4140 pre-hard. We do it in two operations, one in this machine and one in another machine behind us. I'll show you in just a second.
Barry, we're getting ready to make some spindles. Right in here.
You already started, Brian?
Corey, thanks for watching from Australia. This one's kind of hard to see with all the water. There we go. Hi Ben, thanks for watching. Whoa, can't see anything yet. Dave, how many of these spindles do we make, do you think?
We're into the thousands and thousands of them we do a year.
That's awesome. There we go. Now how long does this process take from start to finish?
Start to finish on this one's about 3.5 minutes. Like right now, it's taking a few heavy. You can hear a lot of the banging noises. That's the chips coming off the part. It's doing a roughing operation now, and then it'll start in on all the finished passes.
Hard to see with all that.
The coolant will clear up off the window here in a second once it's done roughing.
Hi Kevin from Ohio, thanks for watching. Hopefully you guys can see that a little bit in there. Hi Stan from Lincoln, thanks for watching. If you guys have questions for Dave, let me know. I'll holler at him. There we go, there's a nice clear picture of it. How many machines do you have over here, Dave?
We have 10 different DMG Mori machines that are all very like new and modern machines.
And you have guys working basically around the clock, don't you? Working on parts?
Yes, we run 2 shifts. We start at 7 in the morning, and then our night shift guys are here till 2:45 in the morning. And then from that time frame, a lot of the machines run unattended by themselves.
That's awesome.
We'll open the door and show you a finished part.
There you go.
This is the finished spindle. It is ready to come out of this machine and go into our next machine, which is our horizontal with the pallet tool, and I'll explain to that here in just a second. It's kind of hard to see inside the cage, but there's a pallet pool around here, and we have multiple jobs running on this machine at any one time, and we manage them off a scheduler. More rear frame.
That one's kind of hard to see through. Let's see if we can get over here. This one right here.
You can show what this screen James is working on here is moving the pallets around on a schedule to show some of them getting machined.
No pressure. Tap all the right buttons.
While James is finishing his pallets, we'll give you a quick view of the rest of the shop.
Yeah, absolutely.
We'll be right back, James. All right. We stage a lot of our parts as different groups as we need them. These are more pallet pieces or platen pieces for scales. These are all parts for steering gears awaiting to be machined. As we get back to the horizontal, we'll kind of go backwards, but these are a lot of finished spindles. These are the finished ones. These are half done off the lathe we just showed you. And then these are all finished steering arms and finished brake brackets that are running on the horizontal. Once we get done with them, we run them through a tumbling process to do all the deburring.
Barry wants to know, how often do you replace the cutting bits on the spindle machine?
It depends on the different tools. It kind of goes by cycles, cutting time, and then just general life in minutes. So depends on the insert, but we try to shoot for anywhere from 20 up to 35, 40 minutes of actual cutting time. And the cutting time is the time it's actually in the cutting material.
Cool. Stuff. What else do you want to go over this way?
Pippin, one of our welders, working on well, we'll see exactly what he's working on. It's a 1935 to 40 bolt-in K member that he's working on the weld jig for that.
Hi Marcia from New Jersey, thanks for watching. That's the weld shop. I won't go in there though.
Within this room we do a lot of windshield frames, and that's primarily all we do. And we start out with raw materials over here on the racks. We bend and roll all the material. Everything gets TIG weld over here, and then the welder actually goes in another grinding room, grinds off the weld, finishes, gets it ready for polishing or chrome, whatever the object is. But this is partially way through the process.
Matt wants to know, do you guys make 37 Ford spindles in-house?
I'd have to check the part number. I'm not positive, but I think so.
It's hard to keep track of everything that we make.
Yeah, a lot of part numbers. This shows the different windshields coming through the process where we roll the material, we cut it, then we roll it, TIG weld it, fill in all the fillets, then we do a rough grinding process, a semi-polishing process, we polish it even more. From this point, it's either to the warehouse as a raw windshield frame, or it goes out and gets chrome.
Pretty cool.
Now we'll have a little peek, see what our other welders are doing.
Yeah.
Looks like Marcus is welding some, by the looks of it, either 58 or 60-inch housings. And by the just general look, I'm telling it's an IMCA spindle for something. Might be a sport mod, or I'm not sure. Trying to get moving.
Yeah, we gotta move it. Yeah. It's wanting to move.
You can chill it moving.
Yeah.
This is the RPP is moving its pallets around to the locations where we want to have them, and that's all based off what we call a schedule. We can schedule different jobs to run at different times, and we can schedule it to run by the part count that we want to have on the finish at the end of the day.
How many cross member kits do we make here? Do you know off the top of your head?
Hundreds
Hundreds.
of different ones.
Yeah. It's hard to see through this cage though. See if I can get a little bit closer. That's not working. Let me back up.
Can you run the pallet that's in the machine?
Let's see here while I'm waiting for them. Hi, Robert from New York. Thanks for watching. Oh yeah, you just asked that question. I see now. We're gonna try and get this machine to move around a little bit for you guys. All these guys are working hard. Oop. What's in this one? A spindle?
This one is running a spindle, and then it'll be running brake brackets. It does a little bit of milling with some coolant, and then once the coolant is done, it'll shut off. There's quite a few dry operations in this one, so visually you'll be able to see a lot better. Spindles on each pallet. We have 2 pallets in the machine, so that while the pallet is in the machine being ran, we can actually be switching parts out of what we call the load station. Hi Al, no, as best of my knowledge, we don't make any 57 old spindles.
Here we go.
It's machining on the back side of the pallet, so you kind of get a little bit better view of the brake brackets on this side of the pallet.
And you can see us in the reflection. We're so cool, huh? is, our warehouse is literally right across the street. Our machine shop is also in the same building as the Museum of American Speed. We'll be at the museum on Wednesday.
I'm trying to wrap it up.
Trying to get a clear shot.
It's hard to see, but here what it's doing is drilling holes with what we call high pressure coolant through the spindle. It just got done drilling 4 holes in about 20 seconds.
Incredible.
At the end of the operations, we have the machine set up so it checks the tools once it's done with the finish.
That's incredible.
It's now tapping the holes in the brake bracket.
Hi Robert from Salt Lake City. Thanks for watching. It's a little loud. Sorry if that was loud in your ear. Hi Shane from Mississippi. Thanks for watching.
Thanks for the feedback, Matt.
Hi, Jonathan in Virginia. Thanks for
This is the fixture where we hold the parts in. It's identical to the ones you guys were just watching, but the spore spindles, they're all clamped in there hydraulically, where we send the oil pressure in and out here. These swing clamps pull it down, and there's 2 4-collet clamps at different angles. This is the back side. These are 2 raw brake brackets. The top is halfway through the operation, so they start out down here, get half machined, we flip them over, put them up here, and then when they come out, they're fully machined. What we call it, this is the tombstones I was describing to you earlier, that this is how this machine runs, is all tombstones.
Cool.
Do you want to watch any more of that run?
We can probably go to something
Okay.
else.
All right. Thanks, James.
Thanks, James. All right, we're gonna head back this way. All these guys are working hard. There's the museum, you can see it right through the window. Okay.
All right, this is Rick Hench. He is one of our guys here, does a lot of programming, setups, fixtures, a lot of new product development. He's going to show you one of our new products we just got done developing.
Hi, this is our new manual steering box that we've been working on for some time. This is the final modeling of what the steering is actually going to look like when it's completed and anodized and completely assembled. So this was a new project that we took on. Our previous manufacturer, Schroeder Steering, discontinued their product line of the manual steering, so we were forced to get into manufacturing of steering, and we wanted to start fresh and really update a lot of the features of the steering that would make it more universal for different types of cars, chassis, from sprint cars to lightning sprints to even boats and TQ midgets. So with this design, what it enables us to do is the center housing is reversible, so we can go from a left-hand steer to a right-hand steer simply by reversing the box.
That's awesome.
And changing the gears inside from a left-hand to a right-hand gear set. So it's very universal. We're using a 2-inch diameter sector shaft tube with needle bearings, and this allows the steering to be positioned more universally in different size cars that the widths may vary. So we're just in the final production stages now, so I know we've got a lot of anxious customers out there that have these steerings on order and need them for the race season, but trust me, they're coming. We're very close. So we're actually working on some of the final parts over here on one of the Mories that we can go over and take a look at there and see, see what's going on.
It's a little bit quieter over here too. Oh gosh.
So this is a prototype version. This is a completed assembled unit, so this is what it's going to look like prior to anodizing. So what I'm manufacturing now is this left side bell housing that supports the sector shaft. And here are the lathe blanks, and this is one of the final 2 parts that we had to put it together.
Neat. Are you in here?
We're in here.
There we go. Hi, Magnus from Sweden. Thanks for watching.
And that probe is locating the part. We use that probe on every part to precision locate that blank when it's in the machine. It's not always required, but on a part like this, it's very critical that we have the concentricity, very close tolerance. That helps control the backlash of the steering gear.
So a bunch of reflection there. Let me see if I can get rid of that. There we go. How long have you guys been working on the design for this?
We started this project in the fall from a design concept standpoint, and came up with a preliminary design, and we had to source the gears. That was the first part, to get the worm gear sets manufactured. And that's quite a precision process. There's not many companies in the States that manufacture the types of gears that we're using here. And then myself and Sean Talley went to work, engineering here at Speedway, and have a lot of hours invested in the design, not just from a quality standpoint, but also universal. We're very encouraged to have the steering as universal as possible for different types of racing.
Yeah. I'm surprised that it didn't take that long. That's awesome to hear that you guys can turn that stuff around that quickly.
We have a lot of resources here, but we also have a lot of products, and one of my new responsibilities here is with new product design and development and getting it from concept to market, quick turn.
Yep. We're so glad to have you over here, for sure.
Our machine shop here is really very state-of-the-art, from all the machines to the tooling to the software that we use. It's state-of-the-art.
Yeah. Trying to get rid of some of that glitter, guys. There we go. Is it just going back through and making final adjustments? Oh, there we go. I spoke too soon, didn't I?
I have a lot of features that are incorporated with that small part, so.
Yeah. That didn't take hardly any time at all for it to completely transform. Trying to stay out of the spray area. to stay out of the spray zone here. There we go.
I know you were watching a couple of jobs run on the horizontal over here, the pallet change machine. Well, one of the pallets you didn't get to see, but is actually set up to run the center housing.
Oh, really?
So those will be completed on that machine
That's awesome.
this week, and along with these side belts over here.
Do we make steering gearboxes in-house?
Roadster.
Or do we source those from
I'm not sure on the steering gearbox, Stan. I think we might make parts for it. I'd have to see the part number to know for sure.
So many parts. Too hard to keep track of them all without a part number. Oh boy.
This right here is kind of a cool little operation. It's hard to see, but what it's doing is three-dimensionally moving up and around the part to put a chamfer on there. Once it's done, I'll hold the part and show you what it just did, but it's just one of the operations we do to deburr parts to make them look nice.
You see Josh's, how do the machines references where they are at on a part to the blueprint loaded in the computer? Part of your comment got cut off, Josh.
All right, Josh, to answer your question, as soon as we get done here, we'll load a new part and we'll show you how it starts off. But this part is programmed in a CAD-CAM package. We use SolidWorks and CamWorks. And we reference a zero position in there. And then once it's loaded in the machine, we use what's called a tool probe, that it probes the part to pick the zero back up to be back on location.
How often does it reference where it's at when it's in the machine?
We reference every single part that we load in here so we know that it's centered on the bore.
See if we can get a better angle of this.
As for maintaining the accuracy, Josh, we're locating it off the probe. It's probably within a couple 10,000ths of an inch, which human hair is 3,000ths. 10,000th would be a human hair divided into 30,000 pieces. 30, excuse me. One too many zeros.
It's Monday, math is hard sometimes. Hi, Harold from Lincoln. Thanks for watching. Ooh. Am I in your way now?
Good. Rick's going to change the part out and we'll show you how we reference the zero in the beginning of it. Might be hard to see, but there's a chamfer all the way around this edge, and that's what I was showing you. We three-dimensionally move the tool up and around there to deburr the part. So now that the part is out, it's completely deburred, ready to go to anodizing.
As you can see here, we have soft jaws that are bored that pulled the part on this shoulder inserts to the center housing. So the location of this final center bore, which is the final tool path that we're going to do on this operation, it's very critical that it is on center with this shoulder. So we use the soft jaws to locate the part and hold it in the vise. And then you can see the probe here. That's the first tool that gets called up. That probe will come over and it will locate the center exactly of this part and every piece that we put in here.
Cool. And it goes.
Yep.
All right.
Now
Oh, now go in there?
Yep.
There we go. So there it's locating it.
You can see the lights flashing. There's an optical sensor on the inside of the machine that picks up all the flashes. And those are interpreted back as data.
There we go. Off it goes again. Cool. Alright. Do you have anything else that you want to show them?
I think I'm done for right now, unless there's any questions.
I don't think so. Yeah, cool.
Gert, to answer your questions, what type of command is used on the machine? All our machines we use are G-code. Most of them are what's called a FANUC or a Siemens base control. Does that answer your question?
Hopefully so. If not, we can chime back on later. Alright, cool. I'm going to come back out here where it's a little bit more quiet and I can keep talking to you guys. Okay, so Bracer Appreciation Week is happening now through Sunday. We have a promo code. Use RAW18 to get some money off your order. Tomorrow I will be in the new Shock Technologies room and the Pro Shock Manufacturing department. So we'll get to see how the new shocks are stacking up. So Shock room is stacking up. So if you have any questions, leave them below. I'll make sure to ask Dave and he can answer all your guys' questions. But for now, we'll see you tomorrow. Have a great afternoon, everybody.